Hello everyone to another update, and it's been a very long time and I was hoping to release this update a lot sooner, but due to some interesting events anyways that have occurred recently, I think it's better that I did do it now instead of doing it earlier, because now we have more information and more understanding. This video is going to be particularly focused on Tropical Cyclone Chido, and this is going to be looking over the past of it and identifying like what it's got to do in the future, as well as looking at our future forecasts for other systems. But generally, okay, as we're looking at the global tropics today, we've got 5 different areas here. One of the areas that was Invest 91S was a tropical depression. It has since dissipated and is now gone, basically like Invest 93S, which is soon to be disappeared as well. No remnant circulation left, and we've got a lot of other areas of interest to discuss, and I think I'll probably cover the other areas first because I think that's best to do. And so we've got a lot of different areas. We've got 91B has been in a slow start, and I might not play through all these loops because some of these loops might lag the video recordings, just because I want to make sure this video recording is salvaged and it doesn't get accidentally errored by clicking all these. The computer's doing a little bit slow processing, but Invest 91B has been progressing all the way through, and I believe the Bay of Bengal, and then it has since moved past Sri Lanka, I believe. And this area is going to be in a situation where there's a low development chance, and I'm not quite sure what the IMD have this for it currently, but the area has been scattered and has been separated of convection consistently, and we can see this through different phases of time. The separate areas of convection, the highest areas of convection, have never congealed, focused, and produced a central area of their interest with a large area of convection being produced in that center. So we've seen its dispersal and its consistency, and we can likely say that there's a lower chance of development, and that this will probably be most of its phase until it passes through to land where it may dissipate. Although in the meantime it will produce high precipitation and will continue these regular bursts of convection as is typical and strong. This is interestingly occurs a lot in the Bay of Bengal, and we have an interesting study I read not too long ago about this theory of the Ekman's current. So the Ekman's current is a theory of the way the surface winds blow across the ocean, and how that affects the transfer of energy below the ocean and the direction of the energy transfer. And what we recognize in the Bay of Bengal actually is that there's normally when you have these spots in the northern hemisphere, they blow from west to east, so you get westerlies, but we've seen an anomalous area in the Bay of Bengal where we've been seeing east to west, so we've been seeing easterlies. And I believe that this, or I might be the opposite, but I'm pretty sure it's this way round, and we've seen that it's enhanced the monsoonal convection, and it may suggest for the way that the convection moves around in the Bay of Bengal, and of course that could be affecting these systems. Obviously it's not like a big serious deal, it's just an anomalous new finding in a study, which I probably would have a screenshot or somewhere to put it up, and probably in the description below if you want to read that. But there's just something interesting to know about that. And now we've got some tropical depression 95P. It was actually the tropical depression, now it's been reduced to subtropical depression 95P. We've had a couple of separate areas of interest in here, and some of them have actually got close but then soon dissipated. Conditions have been quite hostile, and we've seen this convection has separated now, and it is definitely becoming low topped, and that means the convection, the ecotopes, is not reaching as high. And we also seen, like, obviously as per tropical depressions, we have this kind of opened low sort of system with the convection kind of lying around, but not true in tropical nature. And subtropical systems do not have these said fronts, because otherwise they'll be a developed low, and there's not a developed low, so as per it's been named subtropical. And then we've got Invest 96W, which is a scattered area of convection, and we've seen this northern quadrant, this western quadrant, which I've been seeing a little bit interesting, as it is portraying a little bit of that cabbage shape that sometimes you get, where it could spark up new convection and potentially an area of like a lower circulation. But that is something still to watch. It's scattered, it's dispersed, and there's regions that are developing in multiple areas, so you cannot ever define a single area of invest and put that investigation in that particular area, because you can find other areas that may also be part of the actual overall circulation. Sometimes you don't recognize the mid-level circulation along with the lower level circulation. So this is still something that's developing. It's currently in a low chance of development, but obviously as it gets closer to the Philippine area, where and part region, I think in the southern side of like the Philippines, we should start to see chance of development increase and potentially more discussions, of which I'll read out next time in the future update. But as of yet, we've got Cyclone Chido, and I want to just discuss the overall evolution of this system, and we will go through the infrared loop on this. If it does load, we can just make out in the like previously where we can see where the eye is kind of fizzled down like this, because it just made landfall in this region, which I'm gonna have to remember begins with an M, and near Aguilaga Island. Sorry if I pronounced that wrong, but it is within that area made what is considered by this source. By here, we have that it has made landfall here, and yeah, in Aguilaga, and second landfall near Mayoti, and then we do see that as it made Aguilaga, like yesterday, like not yesterday, 3 days ago, made landfall here, where apparently a report was that they had 26 feet of storm surge. I do not know where that report has gone now, but it was listed here by this site that had occurred. And that is very interesting, because obviously that's one of the highest storm surges we've ever seen in a system like this. And it also did say that this, I mean, this is probably during the more intense phase of the system. But although this is a recurrent report that I was looking for, Mayoti, and this is the name of the region that got landfall on recently. And so we think about these people that were impacted, but we've got some reports of some damage and some wind readings. So we've got what is said here, 140 miles per hour reading at the airport, and I'm not sure if that's a gust or that is sustained, but that would suggest that it's probably still pretty high end, and likely still a category 4, and that the HWC still has 115 knots, 130 miles per hour winds on this, so likely it was at this wind speed, which is suggested by the footage as well, which is very intense, if I can find footage of that as well. But this is obviously significant, because if we just go back here and then we play the evolution of the system again, we can see how it's actually regained this northern core, and now it has stabilized this northern part of the system. The most intense winds normally occur on this side, but this is suggestive that this is now a wraparound that could potentially occur and refuel this southern quadrant, and then the eye could potentially clear out as it passes just before the landfall region. So the current thing is that we are seeing a resurge in the convection, and it's very close to land, so we could see high gusts, like a significant frequency of high gusts, which occurred with Hurricane Beryl as it intensified just off the coast. And a lot of people believe it was a lot stronger, but that was mainly due to the bias of the fact that it produced so many of these instantaneous and 3-second gusts. But that is something to watch. And also, one of the things is it's compactified, it's a lot smaller now, and that was partly due to shear and entrainment of air, dry air. But now, as this string has shrinked, it has actually also helped it like a spinner top. It has also helped this convection to wrap around very quickly and potentially allow it for those quick intensification phases that it might have had, like between the landfalls and now. and that there is something to see, because as the things make landfall, we're going to see it do a lot quicker than expected, and so the forecast may not potentially realize that this could be like a really imminent like threat, because it's doing a lot more in the shorter phase of time than is expected to do so. One of the other things is, as per usual with these southern hemisphere cyclones, as it's rotating clockwise, what is considered cyclonic in southern hemisphere, what is anticyclonic here in northern hemisphere, we do usually see these compact tiny systems, and we don't often see a category 4 landfall in like Mozambique. So this is going to be something that's a rare occurrence to also note. And the frequency of these means that people may not potentially be prepared across this coast, because they do not see this all too often. And this small sort of cyclone is something that easily could feed off the boundary of the low sea surface temperatures that are still yet to increase into the peak season, where it currently is in the 27 to 28 degrees sea surface temperatures distribution, and this could easily allow it to strengthen as a small system, whereas a larger system would have to fuel that convection, produce a massive convection, and it can also increase the upwelling, which can decrease the intensity of convection with a larger system. But these southern hemisphere systems, they're crafty, and a lot of them have this capability to intensify very quickly and with high rapid intensification phases. And one of the most really interesting things about these southern hemisphere systems, and I'm not particularly so sure on the absolute reality, like compared to other cyclones, but you can see in one of the floaters that there's a water vapor imagery value, as always mentioned, is as low as minus 10.7 or 10.7 degrees Celsius, and that is like one of the lowest, it's one of the lowest values we have ever seen, and then that is like incredibly significant values that are rarely ever seen, and this could potentially be what's characterizing this system as a category 5 system, because A, it's anomalous and it does not occur with category 4 systems. Secondly, it's also something that occurs when the system's able to dry out its eye, and the infrared readings are able to even pick up on that within the geostationary satellites.